This,
So we have been looking at sample size determination. The last one we looked at was for comparative study, and we talk about different factors that are responsible for how we calculate the sample size. So major factors are the type of variable you are dealing with. We're talking of quantitative or categorical outcome that you want to use. Sometimes a particular study, you can actually, the outcome can be categorical or quantitative at the same time. Sometimes it can only be categorical. So when it is quantitative, you can actually have a cutoff to make it categorical. Like for example, previous anemia study, if you are studying hemoglobin concentration, from there you can talk about prevalence. Even though you can talk about the mean hemoglobin concentration or mean PCV, you can as well talk about anemia. If you study blood pressure, you can talk about mean systolic and diastolic blood pressure. You also talk about hypertension, because once you apply a particular rule or a cutoff, you can change the quantitative to categorical. So whichever way, sometimes there are two approaches to it depending on the type of variable you are dealing with. We also talk about when you are talking of two groups, the two groups may be the two groups are from different set of people. That's what we call independent group. But sometimes it may be, when we talk about group here, in the statistics and research, it's not actually, it may not necessarily mean group of subjects. It's the group of the data you collected. When the group of the data collected are going to be from a separate group of subjects, that is independent group. But when the data set is going to be from the same group of subjects, what you're going to do before and after, that's what we call peer group or dependent group. So we have already said that the peer is misnomer. So we talked extensively the last time. Let's quickly go to so this first one, this set of formula are for independent group. So the first right side is on the left side, rather, is for comparison of proportion. On the right side is for comparison of mean. But when you are dealing with before and after, this look a little bit complex, but it's not actually complex. So the formula becomes this. We talk about that. So we now say today we quickly look at calculating sample size for case control and for cohort study and for experimental design. So you remember that case control, cohort study, experimental or intervention study, and even the comparative, they are all analytical. What makes it analytical is that there is comparison group. So of course, case and control, you know, there are two groups, case and control. Cohort, you also have the cohort and the control. You have experimental is always has comparison group. It may be, but the one many people are familiar with is, oh, we have two separate groups or three groups, they are independent groups. But you can have the same group if you do what you want to do. You know, you take the measurement before your intervention. Then after your intervention, you take the measurement also, you compare. So it's comparison, it's analytical study. So all by design, all experimental design are analytical. As comparison, they have comparison group. So the comparative study is analytical because there's comparison group, but it's an observational study, it's cross-sectional study on two separate groups. Cross-sectional study on two separate. Sometimes also you can see have the cross-sectional where you are not even having two groups. It's the same group, you take your measurement, you wait for some time, believing that some event that happen naturally in the population might have been responsible for some changes. You take it again. It's a form, it's analytical also. So in that way, well, they don't call it comparative, but you are still comparing. It's a better cross-sectional study. What make it well, I think what make cross-sectional is not experimental and is non-longitudinal. Well, it's longitudinal in the sense that you are taking, and later, anytime you take measurement 2 times, it's already a longitudinal study in the sense that there's a follow-up from one time to the other. It's not as if you just go there and there is a cross-sectional study. You do the cross-sectional study, you take sample, and later, after a while, you take another sample, you compare. They are all analytical. Now we want to pin on special cases, case control, cohort study, and experimental design. So we will not go to the nitty-gritty of how some people invented the formula, and you will see, you begin to wonder why not use the same formula for comparative, because it could have gone. But there are some issues around cohort study and case control study that will not allow people to do that type of thing. If you look at what we have here now, you will see that in the one we have for case control and for cohort. Now, you know that when you are dealing with case control and cohort, remember that the outcome are categorical. The outcome are categorical. So you just know that one. When you are dealing with the outcome are categorical. Even if you are measuring a quantitative outcome, somehow it has to change to categorical. That is one. And that is why when you are seeing the formula, you know, the trend we have been bringing is that on the left side, we have the proportion, categorical. On the right side, we have the quantitative. But this one, what we have on the left side is case control. And what we have on the right side is cohort study. And if you look at them, there are something that are similar there, but there are something that are not similar. Here, I want to, this one, you don't even need to cram. Actually, if you want to do that type of study, formula, just know what is most important there is to know what each of the element them. Okay, let's look at the element. And let's start with the case control side. And minimum sample size of case subject required. So standard normal DV corresponding to the level of significance Z. So we already know that when we are talking of N is the minimum sample size. So it can be higher than that, but it must not be less. Because it is believed that if it's less than that, if the difference you are looking for is there, you may not get it. It may be there and you may not get it. That's why it will affect your power. So that is why you go above, you can go above, but you must not go below. That's why it is minimum. So the Z alpha is the same thing. Even from descriptive studies, the standard normal deviation that corresponds with the level of significance. The standard deviation on a standard normal distribution. Then, and when we choose our level of significance to be 0.05 for standard normal deviation, that shows our level of confidence is 95. So the level of confidence and the level of significance, they are complementary, they add up to 100%. If you say your level of significance is 0.05, which is 5%, so your level of confidence is 95. So when you are dealing, in this case now, 95%, when dealing with 2T, 95% level of confidence, the standard normal deviation is 1.96. I think we have seen that one before. We have looked at it before in the previous lecture. Now the power criterion is the same thing also. The power is one thing with the power is usually one-sided. So standard normal data corresponds to 1 minus power. So if you remember, we say the other one corresponds with level of significance. This one corresponds 1 minus power. You remember the 1 minus 1 is the type 2 error. Type 2 error. That's not rejecting our hypothesis when it is false. And we know that it's type 2 error and power that add up to 100%, add up to 1. And when you say 100%, the same thing as 1. So if you choose your power of 80%, the corresponding standard normal deviation is 0.84. Then population prevalence of exposure. Then that is P0, probability of exposure in control. You know, if you if you remember case control study, you start with the cases. It's usually good for rare diseases where you know that in fact, you know, it may take time. This is rare. If you conduct core study, you may waste money. Core study is the most costly work study, even more costly than experimental design that you wait for long. And those, you have to be doing a lot of follow-up, spend a lot of money. But for case control, where it is, you know, if it's for core study now, if the disease is rare, you are waiting for 20 years, you may not even see any case. That's a waste effort. If the disease is rare, in a situation, you know that it doesn't occur, you know, it's rare, but it do occur. But if you start with, maybe you want to use core study to study it, you know, you are going to start with the people that are exposed. Among the people that you are following on, none of them may develop the disease. So that's why the intelligent people, okay, you can use case control, because if the disease is there, all you need to do is to look for people that have the disease pattern. It's that type of disease. If you want to do the study in Nigeria now, you may have to move from center to center, from Maiduguri to Lagos to Ibadan to Ife to Umuahia to Sokoto to different places, to Port Harcourt, and just going to gather different cases. And in that, you may not even see up to 20. For that about, because the disease is rare. So in that situation now, so they talk about population prevalence of exposure. At least population prevalence of exposure. The people that are exposed, what is the prevalence? Then from what the literature, probability of exposure in control. If you look at it now, it gives, everything is giving an impression of, okay, the people that are exposed, because you have already, you have the number of the most of the time, you even have the number of the, you can count the number of people that even have the disease, and you are starting with the disease. So, well, if the disease is very common in that situation, you may be said, okay, you are even picking from there. But if it's a very far method for a rare disease, if it's very dicey thing here, no, then M, you see M now in this formula. M is number of control subject per case subject. Where this one is very, very important is that because the disease, most of the time you use for disease are very rare. You see that, just like what I said, you may do multi-center study, case control, you may not even see up to 20 cases. And will you not say you gather control 20 also, 40? Sometimes when the analysis, the sample size is very small, you cannot bring the meat of the analysis will not come out. You may not get good finding, especially if sometimes you want to look at some factors apart from the one you are studying, because for the fact that you say case exposed case, well, even the issue there's even control and case and control. Yes, you don't even know which of the factors, because you have to want to ask questions about the factor. So the intelligent people now come with the idea that since most of the time is used when disease is rare, you can even double the number of the control. You can even triple it up to tetraple. But believe that if it is more than that, it will not be good. So sometimes what the sample size, the value, the prevalence you are getting may actually influence whether you are going to double or you even use the same. Because if this thing is not so rare, also you can use the same. You can have the same number of cases and control. But the rarer the disease, that is the smaller the number of cases you will get, the more you may have to maybe multiply. You may have to get the multiple of the cases for the control. Now, number of control subject per case subject. Can you see now? So that is the M. So it will affect the formula. So if you say, okay, I want to double it, for me, put it there. The formula, if you look at it, that M is part of the numerator. So the more, if you say you double it, if it is 2 and it is 3, you know the 3 will be more. So the more you want to increase the ratio of the control to cases, the more the sample size will increase. Now, that is for a cohort study, in case control study. Now, you will see for cohort study, you will see the same thing. For the standard normal deviation, for the power criterion, the PO and PY differ. This zero probability of event in control. You know, here, for case control, you start with cases. The people you first see, you know you are starting the study with, you can see are the people that have the disease. But in cohort study, is the people that are exposed. That's the people that are exposed per se. So PO is probability of event in the control. PY is probability of event in the cohort. The cohort as the exposed, the cohort. Like for example, now I want to study the effect of cigarette smoking on lung cancer. Cigarette smokers are the cohort. The word cohort is the word used in borrowed from Roman Empire. The military, the Roman military soldiers there. The cohort are people that are in the army together at the same time. People that are enlisted at the same time, they are the cohort. So here, whenever people that are smoking, maybe people that they are smoker at this point in time, and you gather them, you consider them as a cohort. So you look for control. The control are the people that are not smoking, they are not exposed, but they may be similar in many other things in the society, but they are not exposed to that particular exposure. So the M here is number of control subject per case subject. So sometimes also you want the number of control subject per case. You know this one, though it's not as marked, is not as marked as this other the case control. In the sense that for the case control, we know that disease rate, but sometimes also when you are talking of a particular exposure, the people may not be, it's not something that is common like cigarette now. Or maybe it may not be cigarette, it may be a particular drug or a particular, so maybe people that sniff, what do I call it? Snuff, take snuff. So they are not people also, even though they are not there, there's not as if when you just enter the population, you just see them like that. So you may be taking that line also. So that is, if you look at it, it's just, if you look at the formula now, there are some similarities there. But while the only difference you see there are due to the differences in the, will I say, the process, the research process, and the way you do the recruitment also in the population. So now let's move to experimental design. How do you calculate sample size for randomized trial? So when we talk about experimental design, we have randomized, we have the one that are not randomized. Now when they say randomization, experimental design. Since in experimental design, you try to do something to influence the phenomenon you are studying. That is experimental. Now the hallmark, because since you are doing something, so you must be able to, especially if you gather people want to study them, you must be able to, to ensure that there's no extraneous at the design stage, things that can cause confounding or confounder. Such confounders are removed so that the people you are recruiting to both sides must be the same in all respects. So that if you want to be sure that is whatever you do to this group A that make group A to be different from group B after you take your you take your measurement, you administer your is two. You want to be able to say that is what I did that make the difference. That situation they must be comparable. And randomization just means recruiting. The meaning of randomization is recruiting into subject and control just by chance. By chance. So you recruit by chance. So whether you any that balloting or whatever, the way you select, it's just by anybody that finds themselves in the experimental group, is just by chance that it's not because there was a reason you put the person there. Because if there was a reason, reality can influence the result. So that's randomization. And there are some, when we say randomized trial, there are some experimental design that you don't do randomization simply because you cannot do it. For example, now, if I want to test a drug for hypertension, new drug, all I need to do is to recruit people, all of them, about 200 people that are hypertensive for this study. But I want to give that particular drug to half of them and give conventional drug, the one they were using before, a particular drug, to another half. In that situation, you will see that if I want to be sure that the effects of the drug will not be influenced by who they were before, because I can as well select, because if it is a pharmaceutical company that is sponsored, they say, it must fly. You can as well recruit people that are bad to the other drug, and the new drug people that are not so bad, so that to give impression that, because the one that people that are not so bad, they will respond better than the people that the cases are bad. So if you want to influence that, all you need to do, gather, and just by chance, maybe by balloting, A, B, just for paper, whatever they pick, that's where the person will belong. That is randomization. Then in some situation, imagine you want to know the effect of a particular teaching aid in school. You may go and choose a particular school and use the teaching method or aid, and the other school you didn't use. The issue there is that you are not the one that selected people into those schools. That's their school. So you didn't randomize them. It's not randomized. Because in the situation, there's no way you can randomize. It's not all decision you can randomize. In a situation you cannot randomize, okay, it's not randomized. So I just explained that. In a randomized control trial, you will see that look at the formula, you see that one will come back now to what we said before. That was not applicable to case control and control study. You know, the outcome, whether the outcome is categorical or quantitative. You know, for descriptive, we consider that whether it's a proportion or mean. In comparative, we consider that. In case control and custody, they are categorical. The outcome, they are categorical, the way they are structured. You see, when we get to what I call a measure of association, when we calculate odds ratio and relative rate, you'll be able to understand the reason case control and custody come with categorical outcome. That one, it has to come with that. It's designed to come with categorical outcome. Now you now come back now to experimental. It can be categorical, it can be quantitative. As you see now, this one you may not see much different. You can't even see, it's not that you may not see difference between what we did for comparative study and what you have here. When you're having categorical outcome. But the only thing that may look different is this D square. If you remember that one, you can as well say P1 minus P2, because in comparative, there are two groups in the population, which we are trying to know, you are trying to estimate. There are two separate populations or two separate groups. So you have P1 and P2. Though when you remove one from there, it still give you the D. But in experimental design, what you are looking at is, well, we have different approaches to it. It may be that you are trying to look at a different improvement, or what improvement, or what the range do you expect in the attribute? That is, what increase or what reduction do you expect in the attribute you are measuring? That is what the T is. Otherwise, it's very close to the other one. Now, minimum sample size, standard normal deviation corresponding to the level of significance. Then this is power criteria. Then P1, prevalence of attribute present in the population 1, then in the population 2. You see, if you look at it, this D, if you look at that, let's say D is equal to P1 minus P, minimum expected D. So it may come in different way. You may see that if you are dealing with two groups now, you will see that it's the same. You have to have P1 and P2. Sometimes it may be one group you are dealing with, but though the one group before and after, that one will still come because there is, okay, there's no provision for that. If it is before or after that, if it is the same one group before and after, we are talking of the T. Now let's look at continuous outcome. In a continuous outcome, you will see somebody was asking a question one time that, you know, if you come back to this formula, you will see it's on the pair one. You see the last option I put here for comparison of two means, you will see it's the same thing you have there. So you look at it, the calculation of sample size for comparative study and for experimental, there's no difference there. The only difference lies in the fact that you intervene in one, the other one you didn't intervene. There's no difference. The only difference lies in intervention in one and there's no intervention in the other. And if what you are doing is the same group, you are not even talking of two groups, you will see that surface, even what you do for peer group or peer is the same thing. So when you are comparing two means or you are comparing two proportions, it's virtually the same thing. Either for two separate groups, you see that it's the same thing. For before and after, it's still the same thing. So you will look at it now in the analytical studies, the one that actually differs significantly in the calculation of the sample size is the case control and cohort study. And it's because of the logic behind those studies. Now, the last thing I want to say here, because somebody raised a question the last time, sorry, excuse me, 2 days ago, on Tuesday, when we were discussing calculation of sample size for comparative study. He talked about what I said about non-response. So how do you give room for non-response? I said I will put a slide in this lecture. How will you give room for non-response or attrition? You know, attrition is more applicable in longitudinal study, like all this cohort study, all this experimental design. Attrition is more applicable because when you recruit, you still have to, when you collect your data, you still have to follow them up for some time before you leave them, collect your final data. You will see that some people may fall out. That's at the heart of it. Then sometimes some questions, some people may not even answer some question. That's another thing. So some people may not answer some question, some people may fall out. Whichever way, it will have effect because if you have calculated minimum sample size, it means that anything below that, below that number may not answer the question. So it makes sense that you will have envisaged that what if they don't answer some of those questions? What is the rate of non-response? What if some of them fall out? What is the attrition rate? Whether it is non-response or attrition, so the final sample size, sample here, is n, what you have calculated, over 1 minus non-response rate. So n here is calculated, sorry, I say calculated sample size, non-response or attrition rate, should be or attrition rate. So example, look for example now. A minimum sample size of 300 was calculated for a study. What is the required sample size? If we are to give room for 10% non-response, okay, wrong approach would be by adding 10% to the calculated sample size. So sample, if you add just a 300 plus 30, because 30 is 10%, you give it 330. So if 10% of this 330 go, 10% of 330 is 33. If it goes, what remains, maybe in the field, we have raised 10%. If 10% is no attrition or no response, happen to 10%, you see that what you have left is 297, is less than the calculated minimum sample size. So the correct approach is for you to apply the formula, that formula. We say 300 over 1 minus non-response rate. Non-response rate is 10%. 10% means 0.1. When you remove it, it gives you 0.9. When you divide it, it gives 333. So if you remove 10% of 333 is 33. When you remove it, you see have 300. It's not less than the calculated sample size. So I think we stop here. So I don't know if there are questions. I want questions. What we have the other time. Let's have the question. I don't know if anybody has chatted. I don't think I've seen any chat. So nobody has chatted anything. Any question? If you have
thank you so much, sir.
Okay, welcome.
Thank you, sir. Sir, please, I want to find out about this particular topic that I was given this afternoon by a colleague. It's about outcome prediction following peritonitis secondary to perforated peptic ulcer. They are trying to compare a JAPAPO prognostic scoring system with another kind of, that is Mannheim peritonitis index. So it's a kind of a comparative study. So I want to find out, sir, this type of study that is looking at the prognostic scoring system, because most of I try to go out to look for a lot of materials to help him calculate the sample size. I found out that most of the materials I saw on the net, they were not comparative study formulas. They were using descriptive study sample size formulas. I was now wondering, this is supposed to be a comparative study, but I want to find out, sir, is it a comparative study or a descriptive study, sir?
Okay, any other one? Any other, so that we can take them? Any other person?
Good evening, Dr. Dolapo.
Good evening.
Yeah, my name is Aisha Bello.
Oh,
Season's
welcome,
greetings.
madam. Yeah, welcome, madam.
Thank you.
Yeah.
Please, I don't know. I'm sorry to take you back. My question concerns attrition rate.
Okay.
I want to know specifically the kind of study design that attrition rate can be used for, because we see virtually every design having attrition rate, and I think it shouldn't be correct.
Okay.
Thank you.
Okay, thank you. Okay, maybe why other people? Okay, somebody chatted something. Okay, I saw 4 chat. The slide on right way of calculating attrition on the screen. Thanks so much. Can you see leave? Okay, I will do that. This lecture is very clear and explanation. Thank you. Okay, I will put it back. The question Dr. Omoregbe raised. So it's a descriptive study, it's not this issue. When you were talking, when you say comparative, I was just laughing. So when you now say you see your this, it's not for the fact that you want to test 2 prognostic method through, well, we want to, I don't know, either 2 methods for diagnosis or for assessing prognosis. Does not mean that you are doing comparative study. You know the reason? Because for you to be able to assess those 2 methods, you are going to do it on the same set of people. You understand me? Yes, it's not as if you are going to have group B, group A separately and apply those 2. You are going to measure the same thing to score the same set of people and compare the result. So it's actually a formula for descriptive study. So if, let's say, it is about diagnosis now, what you are trying to see, you are trying to validate that new one. Even for prognosis assessment is more unfair. It's still validation. So what you want to do in the study is to validate, to see, because you have a standard, the one they are using as a standard. And you now have one that is is you are introducing. You want to see this one you are introducing, is it as good as this standard, the gold standard? So from here now, we can know the specificity, the sensitivity, even the predictive value of this new one, using the old one, that standard as the gold standard. So in that type of study, it's not a comparative study. So what you are doing, you are trying to, well, you want to validate a particular either diagnostic or prognostic tool using, because in trying to do that, you must have a standard. I don't know if I've answered your question. Concerning the question, yes, Dr. Bello, our teacher, if you remember, I think I've shared this. Let me share again to be sure. But somebody say I should reshare that thing. I want to be sure that, because I will use it to answer what Dr. Bello asked. If you look at it, say, giving room for non-response or attrition. Attrition is different from non-response. And in trying to, sometimes we use the same formula to whether call it attrition or non-response. The logic behind is that how many people do you expect will go? It will be a percentage of what you are calculated. How many people do you expect will not answer a particular question? When you are dealing with, I think I said in the last lecture, when you are dealing with descriptive study alone, there's nothing like attrition. When there's no follow-up, is not, you can talk about non-response, that people not responding to some question. Some people, when people don't participate, they call it non-response. Well, that's what, especially in development work. When people don't respond, they say it's non-response. If the person rejected, it's not response. But in many researchers, they don't consider that non-response, because if some people don't, they don't want, you sample another person. So anybody that doesn't want, you leave the person, you get another person. So the non-response is calculated from how many people that are doing it. For a particular question now, how many did not respond? What proportion did not respond to a particular question? In most cases, they say in our environment is between 10 to 20% non-response rate. That is non-response. So for this descriptive study, you cannot talk about attrition. Any study that you are not following up, even in a case control, you don't talk about attrition, because in the case control, you get, it's very close to descriptive study in the sense that you sample you get the people that have the disease, you ask them the question, anything you want to do for them, you leave them. Then when you talk about cohort study, experimental design, so there is, you are following up, so you see attrition. So the attrition now, you are talking of cohort study and experimental design. When you are doing comparative study, you don't talk about attrition. But if you are doing the descriptive cross-sectional analytical study, what they call repeated cross-sectional, well, in that case, still, in fact, that one also, you don't even talk about attrition, because what people do is that there is a sample. When they sample now, another time they sample, the person they sample before they ask question, it's not the same person, though it's in the same population. They will not come back and say, we are looking for this person that has our this thing. I want to sample. No, you don't do that. You just sample and you sample again. In that situation, you're not looking for attrition, unless if that one type of design, somebody can decide to come and measure your blood pressure. I don't know, any design that someone will come and do something and now follow the same people want to come and measure. But I'm not saying it's possible, but I've not seen that type of study. But if it happens as a cross-sectional study, repeated cross-sectional study, that if you try to pair, I measure something from you now, I didn't interview, I didn't do anything, but still, believing that something like, just like this COVID-19 now, a lot of things is happening now. Some people may want to know the employment rate. People can study employment at the beginning and at the end. Is there any change? In that situation now, it's a cross-sectional analytical study, it's a repeated cross-sectional. You just take sample, the problem later you take is good. But I don't know, if someone can decide to someone could mark some people also. I know them if they were employed or not employed at the beginning. I go back to them also. If they're employed or not employed, I didn't do anything. But some people call it natural experiment. Natural experiment, that something is happening, but you are not the one causing it. Not like the way COVID-19 is affecting something. If you do it like that, you may talk about attrition. If you pair people, you have already paired somebody, you have already said, okay, I'm coming back to the same person. So some of the people you have there, you may not see them. That's the situation. In the only way you can talk about maybe repeat attrition in that type of study. But majorly you get and see attrition in cohort study and experimental study. Because experimental is you still follow up. You do something, even if it is that you take some measurement, later you do what you want to do, you come back to take, some of them will fall out. They will fall out. So there will be attrition. And attrition is more, for example, if it is a design that is dependent in the experimental design. If it's experimental design that is, even the experimental that is not independent, because you recruit both of them and you have to wait for some time, the people you have recruited to take your measurement from them. So the attrition is with core study and experimental design. Somebody was saying I should leave the slide. I've left it. I don't know if the person has another question. I've left the something. So I don't know if I've answered Dr. Bello's question.
Yes, thank you.
Okay, welcome.
Grateful. Yeah.
So any other one? Okay, if there's no question, actually it's very clear. Okay, that's great. Let me stop the recording.